We just looked at how we can use the string.split. Here we're doing line.split to split the text on white space. And we've used that before. And I'd like to show you that we can also, first off, for demonstration purposes, let me set this a line of text to this. So let's just talk for a second about this method. If I say text.split, it's going to split this into on anything that looks like white space. And notice that the white space is missing from the result. It's going to be kind of crucial to a point that we're going to make later. And so I can also tell it what to split on. That's just the default value. So for instance, if I tell it to split on commas, it's going to split here into father, and then father, and then where are you going? So we get back 3 strings instead of 1, 2, 3, 4, 5, 6 strings. So that's a very handy method to know about if you weren't aware that you can split on any character. It's going to be important to know that we can also we can import the RE module for regular expressions, and we can use re.split, and it works essentially the same way. We tell it what we're going to split on, the pattern that we're splitting on, and here we're just going to say a literal comma, and we're going to tell it to split the text, and we're going to get back the exact same result. So whichever way you'd like to go, that's one way of splitting text. We're gonna really need the RE split method though, because we're gonna get deep into some regular expressions here, because we're gonna try, what we want to do is to break the text into things that look like words and things that don't look like words. So any combination of punctuation and white space is going to be basically a non-word. Quotes are going to be non-words, and a stretch of letters that's what looks like a word. It may not actually be a word, but that's what we're going to shoot for, and we're going to have to use the regular expression module to do that. So let's talk a little bit about how could we define what is a word and what is not a word. So I show here a trick here that if I wanted to create a character class, for instance, of all the vowels, we've seen that here, that we can put all the letters that are vowels into square brackets, and that creates a character class that represents the vowels. So how could we create a character class that would be all the things that are not letters? Well, we've played around before with the string module. We can import string, and then we can look at string printable. So these are all the printable characters that that we have defined here in this module, and we could use this a list comprehension here with a guard to find all the characters that are imprintable that are not in the ASCII letters. So if we look at what are the ASCII letters, it's it's this bit here. So a subset of the string printable. Excuse me. So that's not going to be necessary though, because there are these shorthand classes that we can use, and pretty much every regular expression engine understands these shortcuts. And I say every regular expression engine because you can use, for instance, the grep program on the command line. It's a global regular expression print program, and that understands one set of regular expressions, and then you can actually tell it to use an expanded set too. That probably comes from the Perl compatible regular expressions. I talk a little bit about this. If you go into Perl and you go into Java and Python, they're all going to have about the same syntax for talking about regular expressions and things like shortcut classes. But they're not all going to be exactly the same. So be aware of that. But these ones that we're going to talk about are pretty safe. For instance, \d means all the numbers 0 through 9. Other ways that we could write this would be to explicitly create a character class and list each character 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've also seen that we can create ranges, say 0 to 9. And that has to do with the fact that those letters are contiguous in the ASCII table, something that we'll talk about more in the Gematria chapter. Another one that we can use is \s to talk about white space. And so that's not only a literal space, but also the tab character, the \n for new line, \r for a carriage return, and some other printable bits there that we can't really give a name to. Those are all the same thing as string white space, or we can use in regular expression, we can just use \s to say anything that looks like white space. And so the same is \w. So that is anything that's a word character. That's A to Z, 0 to 9, the underscore, and the dash. Very important that that dash is listed last in a character class, because otherwise it would be trying to interpret it as some sort of a range, like the underscore to something else. But when it sees that dash as the last thing in the character class, it knows that it means the literal dash and not some sort of a range that it should interpolate. So let's look at a given regular expression like this, and let's just play around with this. If we're going to search for \d in the string ABC 1, 2, 3, it tells us it finds the match is 1, because that's the first character that matches a digit in this. Now remember, we are dealing with strings here, so when we say \d, we're saying a character that looks like a digit. We're not finding actual numbers, because regular expressions searching over text, not numbers. But that is a numeric character that we're trying to match. So in the string ABC 1, 2, 3, \d finds the 1, skips over the ABC. We could write the same thing with this longhand. If we were to write out 0 through 9 in square brackets, that's the same thing as \d, which is also the same thing as using the character range. So whichever of these you're comfortable with, they all work the same. \d is pretty universal and is the fewest characters to type, so that's the one I would probably use. Now, I would actually, if I want to make it find 1 or more, I'm going to put a plus sign after that. So \d plus is going to say match 1 or more. And so that's going to match 1, 2, 3. And I try to show that here in the diagram. It matches 1, 2, 3. So if we look at \w and see what it matches, let's look at that. If I tell it to just match 1 of something, it's going to find the A. And I show that here. And if I tell it to match 1 or more, it's going to find almost the entire string, because A, B, C, 1, 2, 3, those are all considered word-like characters. So don't get confused. The word \w does include the numbers. So it's not going to match just the ABC part. If that was all you wanted to match, then you would have to specify, ABC, D, E, F, any of those, and it would find just the letters. Let me put a plus after that, and then it would match just the ABC. So if you were really just trying to match only characters and not numbers, you wouldn't be able to use \w. So just remember what \w includes. If I say 1 or more, it's going to match pretty much the entire string, but it's not going to match the exclamation point. And so moving forward, we'll talk about how to deal with that.